So when you're combining vectors, what you got to think about, I mean, and if you ever take a physics class, you'll learn this in physics too, is it's kind of like it's kind of like here. Let me see if I can't draw something here and move it. So you're going to line up. What you do is you line up. Oh, heck, it's not going to let me move it, is it? Heck. So what you try to see this red vector I just drew. If you can line that vector up, I'm gonna have a hard time making it exactly the same. But it's they call it tip to tail. So the end of that vector goes to the start of that vector. And then what you can have is you have the resultant vector is the side that connects the triangle, okay? And it makes a parallelogram, I'll get into that, but really what we're gonna do is we're adding the two vectors together. In order to add the vectors together, we need to break them into component form. So the thing we've got going here is, let's do some erasing. This came from the textbook, by the way. Let's see. Let me delete that. Yeah, delete that. Then, so what we're going to do is we're going to break. So pretend you've got the dog is the origin, and you get these two vectors, and we've got one vector that has an angle of 18 degrees, and it has a magnitude of 23 pounds. Okay, and then we've got the other vector. Well, now, if you think about that as the positive x-axis, this is the negative 15 degrees, and that has a magnitude of 27. So what we're going to do is break these two. Now we're going to express these into horizontal and vertical form. Those are the components, okay? And they'll look like this. They use the less than greater than signs to indicate it's a vector. And then I think what you've learned up to this point in the work you've done is that, we've got this 18-degree angle. I know that this is 23. I'm going to find the vertical component. I'm going to find the horizontal component. And if you think about that as being the opposite and that being as the adjacent, well, opposite, if I'm looking for the adjacent side, isn't that adjacent over hypotenuse is cosine? So I can think about this as cosine of 18 equals the side I want over 23, which doesn't that become, now I'm going to replace a with x because I want to think about it as a horizontal. Isn't that 23 times the cosine of 18? So that's what goes right here, 23, and we can crunch that with a calculator. Cosine of 18. And then the other one, isn't that going to be the sine of 18 equals y, or opposite, over 23? So that'll be 23 sine of 18. And we can crunch those with a calculator and get decimals. Now the other one is down here. Here, let me do some erasing. Let's see, will it let me erase just that without, yeah. So then the other one, I've got this angle here, and that's actually a negative 15-degree angle. So when I think about this, I know that the x coordinate is going to be positive, but the y coordinate will be negative. So we got to keep that in mind. And if this is, I mean, I could, well, there's two ways to think about this. Isn't the sine of negative 15 degrees the same as negative sine of 15 degrees? Because sine is an odd function, and if you remember an odd function, f of negative x equals negative f of x. So that is going to be the same. Whereas cosines are even functions. So we could treat it this way, and we could just say sine of 15 degrees equals I don't know over 27. And then know that the answer is going to be negative because of this relationship. We can also, because we're using tech, we can also just ignore the even and odd element and just crunch the sine of negative 15. And the calculator is smart enough to know, oh, you're down there in quadrant 4. The sine of negative 15, so that would be So to find the y, the vertical component, we'll do 27 times the sine of negative 15. So we don't have to do any magic with that, any math. And the other one would be 27 cosine of negative 15. Oops, and that's a bracket. Let's put a parenthesis there. Kind of messy, but I think you get it. I think you see it. So then what we're going to do is we're going to grab our calculator. And remember how we talked about that red resultant vector by converting these into decimals so we can add them. And then we're gonna have the horizontal and vertical component of the result. And I don't have a calculator here. All right, just a minute here. Here's my phone. Here, let me stop this video and I'll get a calculator so you don't have to listen to me wander around and find it. Okay, so I found it. So this first vector here works out to be, let's see, let's do the cosine. So I got 21.9 if I do some rounding, and 7.1 if I do some rounding. So that's the horizontal and vertical component of this triangle here. Okay. That vector there. And then I'm going to do the same thing for the other one. Here, you got to bear with me. I haven't keyed this in yet. So let's see, I'm going to do that. Come on. Nope, clearer. I better just type it in. What is it? It's 27 cosine of negative 15 degrees. And I'm getting positive 26.1, and the other one will be 27 sine of negative 15 degrees, and we know this is going to be negative. Oh yeah, so that's negative 7. I'm going to round pretty liberally, but actually that's what it rounds to. I got negative 6.9888. So now those are those two vectors. We could now add these together, and that'll be the x and y, the horizontal and the vertical, that resultant vector I had before. So let's see, what does this add up to? I should be able to do this in my head. What is that? 48, and that's going to be 0.01 or 0.1. So that's the resultant vector. That's the path that the dog is actually going to be pulled in, right? So something like this. Now they aren't asking us that. All they're asking us for is how hard is that dog pulling back on them? Who's corporal? Corporal is the dog. They're trying to look for a magnitude. That's what they're asking. So to find the magnitude, remember, we just do the Pythagorean theorem. And so 48 squared plus 0.1 squared. And then we added them together and take the square root. And basically, it works out to be 48 because 0.01 squared, and then you take the square root. So, and that kind of makes sense. You look at that red vector, that's pretty darn close to the x-axis. So 48 pounds, maybe it's foot-pounds, I don't know, it's not physics. Okay? So that's how you do that. You take the two vectors, you break them down into component form, and notice that I put an XY axis on here, and I did it from the positive x-axis. The next thing with the navigation is going to be a little bit different. So I'll do 44 for you because you can go look up the answers for 43, and then that'll help you do that question on the quiz, on the homework quiz, okay? Now what's different when you're dealing with navigation, bearings, I don't know how much orienteering you've done, bearings are always measured. If this is north, east, southwest, bearings or azimuths, another name for them, are always measured from the north. The compass bearings are different. They're in the quadrants, right? You'll see north 60 degrees east. Well, that's here. That's different from what they're telling us. That's a compass bearing versus well, they're saying a compass heading bearing. They're mixing up their words. Technically, this should be an azimuth. At least the way I learned how to do it, they called it an azimuth. They don't seem to use that word too much anymore, so maybe they've changed their notation. But it's always measured from the north. And in order to do what I just did, you have to have the angle from the positive x-axis. So we got to do a little bit of conversions here before we get too far into it. But here, let me clean this up a little bit so we can get this out. So let's see. This airplane is flying and bearing 170 degrees and at 460 miles per hour. So that's the magnitude, and this is 170. And we want this in terms of the positive x-axis. So if you think about here, you think about that being 0 degrees, and if that's 90, isn't this going to be negative 80 degrees? So to break that up into its components, we're going to do 460 cosine of negative 80. And of course, the cosine of those negative angles in quadrant 4 is positive, so that makes sense. That's a positive number, and the sine will be a negative number. So 460 times the sine of negative 80. Okay, so that's that vector. Now we've got to do the wind. Well, what happens with the wind? Think about that tip to tail thing that I was talking about a minute ago. Here, let me get a different color going here. So that wind has a bearing of 200. So that means it's coming from the direction 200 degrees. So here's 200 degrees, right? That's 180, so it's a little bit more, and it's blowing in that direction. So it's really pushing that plane this way. And if we do talk about resultant here, I got a yellow color, let's use that. So there's the actual path of the plane. Looks to me like, I don't know, it certainly isn't going to be as far down as it was, as far south, and it might not even be as far east, because it might be slowing the plane up a little bit. It's pushing on it, and maybe it's acting like a tailwind. I don't know. It might be far enough out. I know we'll have to figure that out. So we have to break this this wind vector into positive negatives. Now let's think about what's happening here. That x, I think, is going to be positive. That y is going to be, that y should also be positive, looking at that. But that's only if I'm dealing with this angle here. So what is that angle going to be? Well, let's see. If this is, isn't it? It's a vertical angle, isn't it? Isn't that a vertical angle with this and that? Those are vertical angles. So that means they're the same. But, oh, wait a minute. That would be, yeah, no, I think I'm right. I think I'm right with that. So if this is a bearing of 200, isn't this going to be 70 degrees, which would make that 70 degrees? So let's try this. So we're going to say, let's see, how fast is this plane or wind blowing? 80 cosine of 70 and 80 sine of 70. All right, so now let's do some crunching and see what we get. So that's what I got when I did these calculations, and so those are the two component vectors. So now we have to add these together. So let's see, what's 79? I don't want to do that in my head right now, just in case I make a mistake. Truthfully, I need a little more coffee and lunch. But let's see, so 79.9 plus 27.4, I got 107.3, and then negative 453 plus 75.2, right? So that's negative 377.8. So I think I'm okay. I think I'm okay with what I did, because I could believe that this is that's a negative, that's still below the x-axis, and that's positive. Certainly, yeah, that looks pretty good. So now we did the component form of the velocity. Actually, we did a little bit more than that. I did that back here with this one, and then I had to do with the wind. And now they want me to find the ground speed, the actual ground speed, so that's the magnitude. So to find the magnitude of how fast the airplane's flying with the wind affecting it, it's going to be 107.3 squared plus the negative 377.8 squared, and then I'll take the square root. So let's see, bear with me a minute here and I'll crunch that. Let's see, oh good, I can just click and drag, I don't have to type them in. Let's see, so I'm gonna do this squared plus that squared, and then I take the square root. That's like 154,000. I'm gonna take the square root of that. So I got 392 as the ground speed, 392.7. So it is miles per hour, so it is flying slower. The headwind or the tailwind is acting like, or not a tailwind, but this wind is acting like a headwind and slowing the plane down. And then we want to know what direction is it flying in. So what we need to do is, what they're asking us is what is, let's see. I think there's a way to get different colors here. Just a minute. Let me get a different color. Is it letting me do it? No? Okay, here, let me, how about that pretty pink? That might work. Done. So they're asking me, what am I asking myself? This angle here. Looking for this angle here. What's the direction? Not the angle from the x-axis, but what's the direction? If it works out that this is, no, I'm not going to say that. Let's just do this. So they're asking me what's the direction of the airplane. So what we're going to do is we're going to slide this up so I get some space. And I'm going to come back and choose a black pen. Now let's go with blue since that's what's right there. So I've got this triangle formed right here, right? And I'd like to know that angle, and then I'll just add it to 90 degrees, right? Because that's from the positive x-axis, and I gotta go from north. So if this is negative 377.8, and this is 107.3, and I'm looking for this angle, here's the opposite, here's the adjacent. I hope that trips your memory and say, oh, that's just the tangent. So if we know that the tangent of this angle here, that angle right there, equals negative 377.8 over 107.3, don't we do the arctangent to find that? And the nice thing about arctangent, we get output in quadrant, if you think back to segment 1, we get output here in quadrant 1 and quadrant 2. So this will give me the output here, and it's actually going to give me a negative answer. So I'm going to do the arctan. Save myself from writing. I'm going to just say arctan of that. And so I'm going to grab my calculator. Make sure you're in degree mode. And I'm going to do the top divided by the bottom. And then I'm going to do the arctan of that angle. And that's telling me, on my calculator is telling me negative 74.1 degrees. Well, that's the negative angle, and I want to just treat it as a reference angle. I'll add 40 to that. Add 90 to that to get the rest of the angle. So that's going to be what? 164.1 degrees is the new direction. So so the pilot's going to need some compensation for this, isn't to add some compensation. They wanted to fly at 170 degrees, but they're only at 164.6, so they're 6 degrees off course. They'll have to compensate for that, all right? And that's, computers do it all these days, but that's what used to happen. Okay, so that's how we're doing this. I want you to go ahead and try number 43. Look up the answer in the back of the book, and then go try that question. Hopefully this helps. Give a yell if you need some more help. You want to do something live, we certainly can.